When a heavy fighter jet experienced an engine shutdown during drills in the South China Sea, yet still executed a complex feathering maneuver with ease. Did you know what powerful Chinese heart lies behind such extraordinary performance? Recently, CCTV's Military Affairs Time program unveiled the answer. China's independently developed new generation medium thrust WS-19 engine has been formally deployed on the J-35 carrier-based fighter jet. This marks a historic leap for Chinese aviation engines, transitioning from being far behind to keeping pace with global leaders, and even achieving partial leadership in certain areas. This breakthrough not only redefines the performance boundaries of Chinese fighter jets, but also reshapes the competitive landscape in the global aviation power sector. Affectionately dubbed the heart of the J-35 by aviation enthusiasts, the WS-19's leaked performance specifications are truly impressive. It achieves a mean thrust of 7 tons, with maximum afterburner thrust soaring to 11 tons. Its thrust-to-weight ratio exceeds 10, surpassing multiple key metrics of comparable Western counterparts. This entirely domestically designed engine employs an innovative 3+5+1+1 configuration, featuring a 3-stage fan coupled with a 5-stage high-pressure compressor, achieving a total pressure ratio of 35. This significantly outperforms the 30 ratio of the American F414 engine and the 26 ratio of the European EJ200. A higher total pressure ratio enables more complete combustion efficiency and stronger power output, laying a solid foundation for enhanced fighter performance. In materials science, the WS-19 achieves revolutionary breakthroughs. It pioneers the use of China's independently developed silicon nitride ceramic matrix composite material. This advanced material, just 1.2 mm thick, boasts 8 times the hardness of high-strength steel, and withstands extreme temperatures up to 1,600 degrees C. Simultaneously, the engine's turbine blades incorporate a unique cutting-edge self-cooling design. Through precision-engineered internal cooling channels, the blades maintain stable operation at elevated temperatures. Public data indicates its turbine inlet temperature reaches 1850 K, surpassing the European EJ200 by a full 100 K. As a core metric for engine advancement, every 100 K increase in turbine inlet temperature typically translates to approximately 15% more thrust, granting the WS-19 a significant power advantage. Particularly noteworthy is the WS-19's omnidirectional thrust vectoring nozzle technology, granting the J-35 fighter unprecedented 360-degree post-stall maneuverability. During a recent exercise in the South China Sea, the J-35 demonstrated astonishing performance by executing complex feathering maneuvers even with one engine shut down. This super maneuverability provides a lethal tactical advantage in close-range dogfights, enabling pilots to rapidly gain advantageous positions during air combat. Compared to traditional axisymmetric thrust vectoring nozzles, omnidirectional vectoring technology enables more complex thrust vector control, granting the fighter enhanced attitude recovery capabilities and more agile maneuverability. The deep application of digital design technology has injected powerful momentum into the rapid development of the WS-19. During the engineering validation phase, the R&D team employed fully three-dimensional digital collaborative design and simulation technologies to construct a complete digital twin system. This approach achieved over 90% compliance with design requirements and reduced the prototyping cycle by approximately 25% compared to traditional methods. This model-based systems engineering R&D model not only significantly enhanced development efficiency, but also markedly reduced engineering risks, demonstrating the maturity and progress of China's aviation industry in R&D methodologies and project management. When examining the WS-19 within the global competitive landscape of medium thrust engines, its technological advantages become even more pronounced. The American F414G400 engine achieves a maximum thrust of 10 tons with a thrust-to-weight ratio of 8.68. In contrast, the WS-19 delivers a maximum thrust of 11 tons and surpasses a thrust-to-weight ratio of 10, establishing a comprehensive lead. Compared to Europe's EJ200 engine, the WS-19 boasts a 34.6% higher overall pressure ratio and a 100 K higher turbine inlet temperature, indicating greater potential for thrust enhancement. Notably, the WS-19's initial model incorporates an advanced axisymmetric thrust vectoring nozzle, a feature absent in both the F414 and EJ200. Should European or American engines later adopt thrust vectoring nozzles, their thrust-to-weight ratios would further decrease, thereby widening the WS-19's competitive advantage. In terms of bypass ratio selection, the WS-19's 0.5 is slightly higher than the F414's 0.37 and the EJ200's 0.4. Through a higher overall pressure ratio and advanced aerodynamic design, the WS-19 successfully addresses potential high-altitude, high-speed performance losses associated with a larger bypass ratio while achieving low specific fuel consumption. This demonstrates Chinese engineers' precise balancing capabilities and overall design. This design choice ensures fuel efficiency during subsonic and transonic phases, while mitigating potential supersonic performance impacts through complementary technologies, reflecting AVIC's independent technical approach. The J-35 fighter equipped with WS-19 engines has achieved a qualitative leap in overall performance. Classified as a medium-sized aircraft, it boasts a maximum takeoff weight approaching 30 tons, nearing the threshold for heavy carrier-based aircraft. The twin WS-19 engines deliver a combined thrust of 22 tons, propelling the J-35 to a maximum speed of Mach 2.2, significantly surpassing the F-35's Mach 1.6. More notably, the J-35 achieves sustained supersonic cruise, a critical capability beyond the reach of the American F-35. Supersonic cruise capability not only enables faster interception speeds and battlefield responsiveness, but also significantly enhances the aircraft's survivability and attack surprise. In terms of combat performance, the J-35 boasts an operational radius of approximately 1,350 kilometers, carries about 8 tons of internal fuel, and has a maximum payload exceeding 8 tons. Its frontal radar cross-section can be reduced to as low as 0.01 square meters, demonstrating outstanding stealth capabilities. For carrier-based aircraft, the twin-engine design provides greater safety redundancy. Should one engine fail, the aircraft can still safely return to the carrier with the robust support of the other engine, offering unmatched survivability advantages over single-engine carriers. This design philosophy reflects the Chinese aviation industry's profound understanding of carrier-based aviation safety, and precisely addresses the unique demands of carrier operations. Reflecting on the evolution of China's aviation engine development, it has long grappled with core technological challenges. At the dawn of the 21st century, Chinese fighter jets heavily relied on Russian-made engines, with a particularly glaring gap in the medium-thrust engine segment. Through generations of relentless technological accumulation by aviation engineers, China's aviation engine industry has finally entered an explosive growth phase. The WS-10 series engines resolved the fundamental issue of availability for high-thrust engines, while the WS-19 marks China's ascent to world-leading status in medium-thrust engine technology. This journey reflects the complete transformation of China's aviation industry, from technology introduction and assimilation to independent innovation. With CCTV's official announcement of the J-35's operational status, it confirms that the WS-19 has entered mass production and is now in service. Relevant corporate financial reports indicate that the WS-19 series is scheduled for large-scale production starting in 2026, 1 year ahead of the original plan. This signifies that China's carrier-based aircraft fleet will soon be equipped with world-class propulsion systems. The J-35, as deployed on the Fujian aircraft carrier, powered by WS-19 engines, will significantly enhance the combat capabilities of the Chinese naval aviation and profoundly reshape the regional air power landscape. In terms of operational effectiveness, the J-35, leveraging the robust thrust and super maneuverability provided by the WS-19, will hold its own against the F-35 in combat scenarios, potentially even gaining advantages in supersonic performance and maneuverability. From a broader perspective, the WS-19's success represents not merely an engine breakthrough, but a comprehensive leap in China's aviation industrial capabilities. It encompasses synergistic advancements across multiple high-tech fields including materials science, aerothermal dynamics, control theory, and manufacturing processes. This systemic capability development lays a solid foundation for China's future aviation engine progress. Reports indicate that derivative models based on the WS-19 core engine are already in planning, potentially including a low bypass ratio variant for unmanned combat aircraft and a scaled-down version for advanced trainer aircraft, demonstrating the engine's broad application prospects. From import dependency to independent innovation, from catching up and imitation to leading and defining, this has set a new benchmark for China's high-end equipment manufacturing industry. This powerful Chinese heart is propelling the dream of a strong nation and a powerful military, soaring and sailing across China's blue skies and seas.